Title: How Engineers Fit an EKCNE Elevator into a Small Existing Shaft. Who can a small existing elevator shaft support an EKCNE passenger elevator? In many projects, the first answer seems to be no, when the shaft is too narrow, too shallow, or the overhead height is limited. Standard elevator models may only allow a much lower load capacity, but in some cases, the real limitation is not only the shaft size. It is the standard elevator configuration. This is why custom elevator engineering matters. Especially in existing buildings, commercial renovations, and retrofit projects. Main explanation: in elevator projects, capacity is not decided by load rating alone. Engineers also need to evaluate shaft width, shaft depth, overhead height, pit condition, door arrangement, guide rail layout, safety clearance, installation space, and local compliance requirements. A standard catalog elevator may fit the shaft, but it may not use the available space efficiently. This is common in existing buildings. The building structure is already fixed. The shaft cannot easily be expanded. The roof cannot always be modified. The client may need higher passenger capacity, but the available space is limited. The engineering question becomes, how can we use the existing shaft more efficiently without creating unsafe or non-compliant conditions? Project example: one example is a commercial elevator project in Spain. The existing shaft measured only Fe mean width and Fe team in depth. For this shaft size, standard elevator configurations were typically limited to around EKCNE to EKCNE. The client needed a higher capacity elevator, faster installation, strong durability, and compliance with European safety requirements. There was another major constraint: overhead height. Traditional commercial elevators often require around FEM to FEM of top clearance. But this building could not easily provide that height without costly structural modification. So the challenge was not simply to install an elevator. The challenge was to increase capacity, reduce overhead demand, and avoid unnecessary building modification. Engineering solution for this project: EKCNE's engineering team developed a custom elevator configuration using a partially integrated structural design. The result was an EKCNE capacity elevator designed for the existing FEM shaft. The required overhead was reduced to FEM, instead of the typical FEM to FEM required by many traditional commercial elevator configurations. This matters because lower overhead can help avoid roof modification, reduce civil work, and make the project more realistic for existing buildings. The partially integrated structure also helped reduce the number of loose components on site. That can make installation more efficient, reduce assembly complexity, and improve long-term structural stability. But the key point is not simply higher capacity. The engineering point is that space efficiency, installation method, structural layout, and compliance must be evaluated together. Why compliance still matters when engineers try to maximize capacity in a small shaft: safety cannot be treated as flexible. A compact elevator still needs to meet relevant safety standards. For a European project, ENFE compliance remains a critical design requirement. This means the elevator must not only fit the shaft, it must also provide proper safety clearance, structural reliability, door operation, control logic, and installation feasibility. A custom solution is not about forcing a bigger elevator into a smaller space. It is about designing a configuration that the building can realistically and safely support. Buyer checklist: if you are planning an elevator project in a constrained building, do not start only by asking, what load capacity do we need? Instead, ask, what are the exact shaft dimensions? What is the available overhead height? Is roof modification possible or too expensive? What pit depth is available? What door opening arrangement is required? Can the structure support the load path? Will the installation method reduce or increase site complexity? Does the solution meet local safety standards? Can a custom configuration improve usable cabin space? These questions help determine whether a standard elevator is enough, or whether a custom engineering solution is needed. Conclusion: is it realistic to fit an EKCNE elevator into a small existing shaft? Sometimes, yes, but only after proper engineering evaluation. The Spain project shows that a constrained shaft does not always mean the lowest possible capacity. With the right structural layout, low overhead design, and compliance review, it may be possible to improve capacity while reducing building modification. For more details about EKCNE Spain, EKCNE custom elevator case, you can read the original project article here. https://EKCNE lift. Com EKCNE custom elevator small shaft Spain.